2.5 sixth sum. By the principles of mathematical induction, prove that a power n minus b power n is divisible by a minus b for all n is the element of a natural number. Solution. Let the statement be Pn. Step 1. Step 1. That is Pn is equal to a power n minus b power n. P1 left hand side. Sorry. P1 is equal to a power 1 minus b power 1. That is a minus b divisible by a minus b. Therefore, P1 is 2. Step 2. Let us assume that Pk is true. That is Pk is equal to a power k minus p power k is divisible by a minus b. That means a pk is equal to m into a minus b. That is pk is equal to m into a minus b. Step 3. To prove Pk plus 1 is true, Pk plus 1 is equal to a power, instead of k we should substitute k plus 1 minus b power k plus 1. That is, add and subtract. This to prove this sum, we should introduce some changes. That is, add and subtract a power k into b. That is, p of k plus 1 is equal to a power k plus 1 here. First subtract a power k into b and add a power k into b minus b power k plus 1. Take a power k here, that is equal to, we can change this as a power k into a power 1, that is a, minus a power k into b plus a power k into b minus, we can change this as b power k into b power 1 is b. Take common. Here a power k is common. That is, here is a minus a power k is taken out, then b is here. Here we can also take a, here also b is common here, and a power k minus b power k. Therefore, we know that this is a power a minus b. Here is a minus m into, we know that this is m into a minus b. That is a power k into a minus b. By step 2, we can change this b into m into a minus b. That is a minus b common. Then here is a power k plus bm. A minus b is multiplied, therefore in the that statement is divisible by a minus b. Therefore, pk plus 1 is true, and hence pn is true for all value of n. Exercise 2.5 seventh sum. By the principle of mathematical induction, prove that 5 power 2n minus 1 is divisible by 24 for all n is element of capital N. Solution. Let Pn is equal to 5 power 2n minus 1. P1 is equal to 5 power 2 into 1 minus 1. 5 squared is 25 minus 1, that's equal to 24. Divisible by 24. Therefore, P1 is true. Step 2. It is step 1. Step 2. Let us assume that pk is true. Pk is true. That is, pk is equal to 5 power 2k minus 1. Therefore, that is, pk is equal to 5 power 2k minus 1 is equal to multiplied by 24 means 24 into m is true. Then step 3. To prove pk plus 1 is true, pk plus 1 is equal to 5 power, instead of k we should put 2 into k power k plus 1 minus 1, that is 5 power 2k into, that is 2k plus 2 minus 1, 5 power 2k into 5 power 2, we can change this like that, minus 1. 5 squared is 25 minus 1. We can change this 25 as we are going to prove that it is multiplied by 24, then change this 25 as 24 plus 1. 5 power 2k into 24 plus 1 minus 1. Remove the bracket. 5 power 2k into 24 plus 5 power 2k minus 1. This is, we know that this is 5 power 2k into 24. By step 2, this value is 24m. Take common 24. 5 power 2k plus m multiplied by 24 means it is, therefore it is divisible by 24. Therefore, pk plus 1 is true. and hence Pn is true for all value of n element of capital N. That's all.